When an Earth student joins the Galactic Academy of Sciences, their seemingly primitive approach to survival training shocks their alien classmates. But as they explain why Earth is classified as a death world, the aliens begin to understand that humans' adaptability and resourcefulness arise from evolving on the most dangerous planet known to the Federation. In the uppermost spire of the Galactic Academy of Sciences, where the artificial gravity grew thin enough for gas-based life forms to attend classes comfortably, Lyra Voss was giving her first presentation of the term. The topic was simple enough: early survival experiences that influenced career choices. She hadn't expected it to empty 3 seats in the front row. To clarify, her tentacled classmate Rizix interrupted. Emergency filters deploying across its respirator. You willingly entered an active volcanic zone? For entertainment? Well, yeah. Lyra adjusted her holoscreen display, showing footage from her family's vacation to Yellowstone. Most Earth families visit at least one supervolcano during their children's education. It's part of our standard geological appreciation curriculum. The crystalline form of Professor Ixleth vibrated with such intensity that their teaching assistant had to adjust the harmonic dampeners. Around the lecture hall, environmental suits whirred to maximum protection settings, and several gaseous students compressed themselves into defensive spheres. You expose your offspring to geological instabilities? As education? The professor's voice emerged in carefully measured frequencies. And this is normal? Lyra glanced around the amphitheater, suddenly aware that her classmates' reactions weren't the usual academic interest. The Mist Collective representatives had condensed into tight, worried orbs. The silicon-based Patroxy had shifted their crystalline structures into defensive formations. Even the quantum probability clouds of the nth dimension exchange students had collapsed into solid states of alarm. Of course it's normal, she continued, puzzled by their response. How else would children learn about tectonic activity? We combine it with camping trips. That's where you practice survival skills in hostile environments for fun. My family did the Ring of Fire tour when I was 8. 20 active volcanoes in 2 weeks. A Patroxy student calcified entirely. 2 Mist Collective spheres departed through the ventilation system. Professor Ixleth's crystalline lattice took on a deep ultraviolet hue that Lyra had never seen before. Ms. Voss, the professor's harmonics shifted to formal emergency frequencies. Please pause your presentation. There seems to be critical information missing from your species orientation package. According to galactic safety protocols, exposure to active geological formations requires Class 7 environmental shielding, and they consulted their data crystal. And you said you were 8 cycles old, without protective equipment? Oh, we had equipment. Lyra brightened, pulling her standard-issue survival kit from her bag. Basic thermal gear, gas mask, emergency beacon, water purifier, rad shield. Though we barely needed it, except for that unexpected pyroclastic flow on day 12. Mom said it was great practice for future field research. The silence that followed was broken only by the soft hum of failing environmental suits as several more students evacuated the chamber. Rizix's tentacles had coiled into tight protective spirals, their chromatophores flashing warning pattern. Professor, they managed through their enhanced filter system. I believe this explains the anomalous readings from my research project. Remember when our instruments detected trace amounts of multiple lethal compounds in her respiratory system? Ah, right. Lyra nodded enthusiastically. That's probably from my deep-sea vent diving certification. Or maybe the methane lake survival course. Though it could be residual effects from that summer I spent studying extremophile bacteria in acid caves. It's hard to keep track sometimes. Earth has so many interesting hazardous environments to explore. Professor Ixleth's crystal structure emitted an emergency stabilization tone. Class dismissed, they announced. Ms. Voss, please remain. We need to have a very serious discussion about your planet's classification status in the galactic database. After the last panicked student fled the lecture hall, Professor Ixleth's crystalline form stabilized into a stern academic configuration. With a gesture, they activated the chamber's holographic array, filling the space with a complex 3-dimensional display of planetary classification matrices. Ms. Voss, they began, neural pathways flickering with contained agitation. What do you know about the Galactic Federation's Planetary Habitability Index? Lyra consulted her datapad. It's a basic rating system, right? Class 1 through 5, measuring how easily different species can colonize new worlds. A sound like breaking glass emanated from the professor as their crystalline structure vibrated with distress. The remaining students, those whose environmental suits hadn't malfunctioned from shock, shifted uncomfortably in their seats. The PHI system, Professor Ixleth corrected, spans 12 primary categories and 47 subcategories, measuring everything from gravitational constants to atmospheric composition. The hologram shifted, displaying a cascade of planetary data. Perfectly stable geology, optimal radiation levels, no dangerous flora or fauna, perpetual climatic homeostasis. The display showed serene worlds of gentle hills and calm seas. Rizix's tentacles relaxed slightly at the soothing imagery. Below that, the professor continued, we have the standard habitable worlds, minor seasonal variations, manageable wildlife, occasional weather patterns requiring basic environmental protection. Most civilized species evolve on these worlds. Lyra nodded along, wondering why this basic material warranted an emergency review. Then the hologram shifted again, colors darkening. Further down, we encountered challenge worlds planets requiring significant technological intervention for colonization. Extreme temperature variations of up to 15 degrees. Seasonal weather patterns. Simple predatory life forms. The professor's tone grew more serious. Below that are hostile worlds where even advanced civilizations struggle to establish permanent settlements. The display now showed worlds of swirling storms and active volcanoes. Several students activated additional protective shield. And finally, Professor Ixleth's voice dropped to a resonant whisper. We have the theoretical classification known as DEATHWORLDs, planets so inherently dangerous that the original architects of the PHI system included the category purely for mathematical completeness. No one believed such worlds could actually support advanced life. With another gesture, the professor brought up Earth's planetary data. Red warning indicators flashed across every category. Your world, Ms. Voss, experiences temperature variations of over 50 degrees. It has active plate tectonics, resulting in constant geological instability. Your atmosphere contains enough free oxygen to power industrial furnaces. Your background radiation levels exceed safety protocols for most species. Your gravity is 30% above galactic standard for habitable world. Your planet harbors millions of species of potentially lethal microorganisms. Your oceans, covering 70% of the surface, are composed of a universal solvent. And your species evolved alongside multiple apex predators in every ecosystem. Each point appeared in the hologram, accompanied by detailed scientific readings. Lyra found herself leaning forward with growing interest. But most remarkably, the professor continued, their crystal structure pulsing with academic intensity. Your species doesn't merely survive these conditions. You actively seek them out. You deliberately expose your young to environmental hazards as education. You intentionally visit geological disaster zones for recreation. You willingly immerse yourselves in high-pressure hydrogen dioxide for sport. Well, Lyra interjected, how else would we learn our limits? My little sister just joined her school's junior volcano monitoring club. They're learning to predict eruptions by analyzing gas emissions. She's hoping to qualify for the advanced spelunking team next year. The professor's crystalline form briefly lost coherence. Rizix's emergency filters cycled into overdrive. The remaining Patroxy student began to oscillate in distress. Ms. Voss, Professor Ixleth managed after a moment of resonance gathering. I believe it's time we discussed why Earth's classification was recently updated from DEATHWORLD to a unique new category. Active DEATHWORLD, sapient species, inexplicably thriving. The hologram shifted one final time, showing Earth in all its dangerous glory. A swirling mass of storms, tectonic activity, and biological complexity that made even Lyra pause. She'd never seen her home world quite like this before. Through alien eyes, it was beautiful, in a terrifying sort of way. Lyra's classmates, who had fled during her initial presentation, began cautiously returning to the lecture hall. their environmental suits now reinforced with additional protective layers. The holographic display of Earth continued to rotate slowly, each geological and atmospheric feature tagged with warning symbols that pulsed in angry crimson. Perhaps, Professor Ixleth suggested, their crystalline forms still showing traces of ultraviolet distress. Environmental challenges on a daily basis. Lyra stood up, moving closer to the hologram. She pointed to a particularly active volcanic region in the Pacific. Well, take the Ring of Fire. We've built some of our largest cities right along these tectonic boundaries. Tokyo, Seattle, San Francisco. Millions of people live there. We've developed architecture that actually sways with the earthquakes, instead of trying to resist them. The Patroxy student's crystalline surface crackled with static. You construct habitation units to move with geological instability? Exactly. Lyra brightened. And that's just the beginning. We've got tsunami warning systems that can detect waves hours before they hit, weather satellites that track our planet's 4 simultaneous hurricane systems, and apps that alert you when the air becomes too toxic to breathe during wildfire season. She pulled up her personal datapad, displaying her hometown's emergency alert system. The screen showed a dozen active warnings. Moderate earthquake risk, high UV index, elevated pollen count, riptide advisory, flash flood watch, and an air quality warning due to an offshore volcanic eruption. This is from yesterday, she explained. Pretty quiet day, actually. Oh, and here's my family's basic emergency kit inventory. She scrolled through an extensive list of supplies. It's just common sense, really. Professor Ixleth's neural pathways flickered rapidly as they processed this information. And these conditions, they exist across your entire planet? Oh no, Lyra laughed. Each region has its own unique hazards. The equatorial zones deal with hypercanes and flash floods. The polar regions have killer ice storms and predators that have evolved to hunt in total darkness. The temperate zones get everything from tornadoes to blizzards, sometimes in the same week. That's why we start teaching weather pattern recognition in preschool. Rizix's tentacles coiled tighter with each new revelation. Your education system deliberately prepares infants for multiple environmental catastrophes? Of course, by age 5, most kids can recite basic survival protocols for at least 10 different disaster scenarios. My niece just won her school's annual earthquake drill competition. She set a new record for constructing a stable shelter using nothing but classroom furniture. The hologram shifted to display Earth's biological diversity metrics. The numbers caused several students' universal translators to glitch and restart. According to these readings, Professor Ixleth noted, their voice modulating with academic fascination, your planet harbors over 8 million known species, with an estimated 10 million yet to be classified, and a significant percentage of these are potentially lethal to sapient life? Oh, way more than that. Lyra pulled up her own research data. We're discovering new venomous species almost daily. There's this fascinating spider we just identified in my grandmother's garden that can paralyze small mammals with a single bite. The anti-venom research possibilities are incredibly exciting. The remaining Patroxy student finally succumbed to emergency hibernation mode, their silicon-based form crystallizing with an audible. 2 of the returning students immediately reversed course and exited through the emergency decontamination chamber. Professor Ixleth's form pulsed with a new color, a deep iridescent sheen that suggested both horror and intellectual excitement. Voss, I believe your species' approach to environmental adaptation may require us to revise several fundamental theories about sapient development. Would you be willing to participate in an extensive study of human survival strategy? Lyra grinned. I'd love to. I've actually been working on a thesis about how extreme environments drive evolutionary innovation. Did you know we recently discovered bacteria living in radioactive waste that can metabolize plutonium? The applications for space exploration are fascinating. The professor's crystalline structure emitted a high-pitched harmonic that caused the remaining environmental suits in the room to activate their emergency stabilization protocols. This, they realized, was going to be a very interesting academic. Professor Ixleth's suggestion for a practical demonstration led them to the Academy's environmental simulation chamber, a massive hexagonal room designed to replicate conditions from any known habitable. Lyra stood in the center, while her classmates observed from behind quantum-reinforced safety barriers. Their environmental suits upgraded to maximum protection protocol. "We'll begin with standard Earth conditions," the professor announced, their crystalline form positioned at the control interface. "Ms. Voss, please verify the parameter." The chamber hummed to life. Lyra felt the familiar embrace of Earth normal gravity, the comfortable pressure of nitrogen-oxygen atmosphere, and the subtle warmth of simulated solar radiation. She took a deep breath, savoring the taste of water vapor in the air, something that had terrified 3 different species during orientation. Gravity at 9.8 meters per second squared. Atmospheric pressure at 101.325 kilopascals. Temperature at 293.15 Kelvin, she confirmed. "Though you might want to add some particulate matter to make it more realistic. Earth's atmosphere usually has a healthy mix of pollen, dust, and volcanic ash." The professor's neural pathways flickered in what Lyra had learned to recognize as academic concern. "Perhaps we should focus on basic survival responses first. How does your species typically prepare for environmental variation?" Lyra pulled her standard emergency kit from her bag, laying out its contents. Basic survival gear. Every human carries something like this. Water purification tablets, because you never know when a water source might be contaminated by anything from bacteria to radioactive isotopes. Multi-tool for improvising shelter or emergency beacon, though it's usually unnecessary since we can triangulate position using seismic tremors. If Rizix's tentacles writhed in fascination. "You navigate using geological instability?" "Sure. If you can feel 3 distinct tremors, you can calculate your position relative to any known. It's one of the first things we learn in wilderness survival class, right after tracking predators by their hunting patterns." The chamber's sensors registered elevated stress patterns from the observation. Professor Ixleth quickly intervened. Perhaps a practical demonstration of environmental adaptation would be more illuminating. "Shall we simulate some typical Earth weather conditions?" Lyra brightened. "Oh, let's do a Category 3 hurricane. That's usually a good starter for understanding Earth's atmospheric dynamic." Before anyone could object, she accessed the environmental controls. The chamber's atmosphere began to swirl, pressure systems building rapid. Wind speeds increased as the simulated temperature dropped sharply. In the observation area, several students activated their secondary containment field. "Notice how the wind patterns develop," Lyra lectured, her voice carrying clearly despite the growing storm. "You can predict intensity by monitoring the barometric pressure gradient. We teach children to recognize the signs by having them build miniature weather stations as science projects." The chamber's safety systems suddenly blared a warning. Something in the atmospheric circulation matrix had destabilized, causing cascade failures across multiple environmental control. Warning lights flashed as simulated conditions began fluctuating wildly. "Emergency shutdown," Professor Ixleth ordered, their crystalline form resonating with alarm frequencies. "All observers evacuate immediately." But Lyra was already moving. In the chaos of failing systems and panicking aliens, she demonstrated exactly why humans had survived their death world of origin. Her reactions weren't learned, they were instinctive, bred into her species by millions of years of adapting to a planet that constantly tried to kill them. She rapidly assessed the chamber's structural weaknesses, noting the pattern of system failures. While her classmates rushed for the exits, she moved deeper into the malfunctioning chamber, using her multi-tool to access an emergency maintenance panel. "The atmospheric circulation matrix is overloading the primary containment field," she called out, fingers flying over the controls. "But if we reroute power through the secondary systems and use the gravitational stabilizers to counter the pressure differential." Professor Ixleth watched in astonishment as their human student not only remained calm in a crisis, but actively worked to resolve it. More remarkably, she seemed to be enjoying herself. "Just like the time our house's environmental systems failed during a mega blizzard," Lyra commented cheerfully, bypassing another failing circuit. "Though this is actually easier since there's no risk of flash freezing." "Professor, could you adjust the quantum harmonics to compensate for the power fluctuations?" Working together, they managed to stabilize the chamber's systems. As the simulated storm dissipated, Lyra emerged from the maintenance access, her hair slightly disheveled, but her eyes bright with excitement. "That was fascinating," she exclaimed. The way the containment field interacted with the atmospheric matrix, it's given me some great ideas for my thesis on adaptive response patterns in crisis situations. Do you think we could try reproducing the malfunction under controlled conditions? The observation area had emptied during the crisis, but the monitoring systems recorded everything. Professor Ixleth's crystalline form pulsed with colors that suggested both academic excitement and existential dread. "Ms. Voss," they said carefully, "I believe you have just demonstrated why your species classification requires its own unique category. No other known sapient race would respond to a catastrophic system failure by attempting to..." Lyra was already reviewing the chamber's diagnostic logs. "Just wait until I tell you about how we study actual natural disasters. My old university has a whole department dedicated to chasing tornadoes. They drive right up to them in specially reinforced vehicles. The data collection methods are incredible." The professor's neural pathways briefly shorted out as they contemplated this new information. The humans didn't just survive their death world. They pursued its deadliest phenomena for scientific. Perhaps it was time to reconsider the entire concept of normal environmental adaptation. In the aftermath of the simulation chamber incident, Professor Ixleth convened an emergency faculty. The chamber's recorded data played in the center of the conference room, showing Lyra's response to the crisis from multiple angles. Department heads from across the academy watched in fascinated horror as the human student deliberately moved toward danger, improvising solutions. "The implications are unsettling," declared Dean Vexthor, their quantum probability field fluctuating with. "We've always assumed that sapient species develop intelligence as a means to avoid environmental dangers. Yet humans appear to have evolved intelligence specifically to engage with." Professor Ixleth's crystalline form shimmered with academic excitement. "Indeed. Consider their educational methodology. While we teach our young to maintain environmental stability, humans deliberately expose their children to control. They don't just survive their death world. They've built their entire civilization around studying and exploiting its danger." The holographic display shifted to show Lyra's vital signs during the chamber mouth. Where any other species would have shown panic responses, her readings indicated heightened focus and, most disturbingly, elevated levels of pleasure. "She was enjoying it," murmured Dr. Jara, the xenobiology department head. Their gaseous form swirled thoughtfully in its containment field, just as she described their storm chasers and volcano monitoring clubs. Humans don't merely tolerate dangerous conditions, they find intellectual stimulation in studying. The implications rippled through the assembly like a gravitational wave. Every advanced species in the galaxy had achieved civilization by creating stable, controlled environments. Humans had done the opposite. They'd thrived by learning to adapt to chaos. "Their neural architecture is fascinating," contributed Dr. Nexil, the Academy's chief xenopsychologist. "Where most species develop trauma responses to environmental threats, humans show increased cognitive function under stress. They actually think more clearly in crisis situations." The display showed Lyra's brain activity during the chamber incident, complex patterns of activation that suggested both analytical problem-solving and creative improvisation occurring simultaneously. It was unlike anything in the Academy's extensive xenological data. "But most remarkably," Professor Ixleth added, "they've developed cultural frameworks to pass these adaptive capabilities to each new generation. Their disaster preparedness programs don't just teach survival, they instill a fundamental comfort with environmental chaos." The assembly contemplated this. The concept of deliberately teaching young to embrace environmental hazards challenged the very foundations of galactic educational theory. "Perhaps," suggested Dean Vexithor, their probability field stabilizing into a decision pattern, "we've been approaching human integration from the wrong perspective. Instead of trying to protect them from what we consider dangerous conditions, we should be studying how they turn environmental challenges into opportunities for growth." The assembly's attention returned to the simulation chamber. They watched again as Lyra calmly diagnosed the system failure, improvised solutions, and even proposed studying the malfunction for future reference. It was becoming clear that human adaptability wasn't just a survival trait. It was a fundamental approach to understanding the universe. "We've been thinking of Earth as a death world," Professor Ixleth concluded, their neural pathways pulsing with revelation. "But for humans, it's simply home. Every aspect of their biology, their psychology, even their educational systems has evolved to thrive in conditions we consider catastrophic. They don't need our protection. They need our recognition of their unique capability. The implications for the Academy's curriculum were if one species could evolve such radically different approaches to environmental challenges, how many other assumptions about sapient development might need to be reconsidered? As if to emphasize the point, a notification appeared in their communication network. Lyra had submitted a formal request to repeat the chamber malfunction under controlled conditions, along with a detailed proposal for studying system failures as a means of improving emergency response protocol. Dean Vexthor's quantum field rippled with what might have been amusement. It seems, colleagues, that we have much to learn from our humans. Perhaps it's time to reconsider what we mean by standard environmental parameter. The assembly agreed. The age of predictable, controlled academic study was about to meet its greatest challenge: human curiosity about chaos itself. The revelation about Earth's unique status catalyzed unprecedented changes at the Galactic Academy of Sciences. What began as a single student's casual presentation evolved into a complete restructuring of the xenobiological adaptation. The Academy established the DEATHWORLD Studies Initiative, with Lyra Voss appointed as its first human consultant. Training simulations were redesigned to incorporate human-style adaptive response. While most species still relied on their technological solutions, they began learning alternative approaches based on Earth's survival principles. Vassaran environmental suits now included manual override systems inspired by human emergency protocols. Petroxy students practiced basic movement techniques without their standard stabilization fields, learning to respond to unexpected changes in their environment. The influence extended beyond the Academy's walls. Diplomatic delegations from across the galaxy arrived to study human adaptive capability. The Cloud Folk Collective, renowned for their environmental sensitivity, began incorporating modified versions of Earth's weather prediction systems into their atmospheric monitoring net. The quantum gestalt representatives found particular fascination with humans' ability to make rapid decisions under chaotic conditions. Lyra's role evolved from student to teacher as she helped develop new training programs. The key isn't just surviving extreme conditions, she explained to a mixed species class, practicing basic emergency responses. It's understanding that chaos itself is a fundamental part of the universe. Every environmental challenge is an opportunity to learn, and the most profound change came in the form of cultural exchange. As alien species began to understand the unique pressures that had shaped human development, they shared their own evolutionary strategies. The Vassarans taught humans their sophisticated environmental monitoring techniques. The Petroxy shared their methods for achieving perfect stillness in geological events. The Cloud Fork demonstrated advanced atmospheric pattern recognition that even Earth's meteorologists hadn't discovered. Together, they began developing hybrid approaches to survival, combining human adaptability with alien technological precision. What had started as a shocking revelation about one DEATHWORLD species became a revolution in understanding how different evolutionary paths could complement each other. In the years that followed, Earth's classification in the galactic database evolved once again. While it retained its active DEATHWORLD status, a new notation was added: origin of adaptive crisis response theory. The term DEATHWORLD itself underwent a semantic shift, coming to represent not just environmental hazards, but the remarkable adaptations they could produce. The Academy established permanent exchange programs with Earth universities, leading to breakthroughs in environmental adaptation technology. Human emergency response protocols were integrated into galactic standard training, while Earth's disaster preparedness programs began incorporating alien technological innovation. Lyra completed her studies and became the Academy's first professor of human adaptive strategies. Her thesis, Dancing with Chaos: Evolution Under Extreme Environmental Pressure, became required reading across multiple fields of xenological study. But her greatest contribution was helping bridge the gap between radically different approaches to survival. As she wrote in the conclusion of her widely published research, the universe doesn't differentiate between paradise worlds and death worlds. These are merely labels we assign, based on our own evolutionary perspectives. True adaptation isn't about avoiding environmental challenges or overwhelming them with technology. It's about learning to thrive within them, understanding them, and ultimately growing stronger through facing them. Perhaps that's the greatest lesson Earth has to teach the galaxy. There is no such thing as an inhospitable world, only unprepared species.